Continuing into our stoichiometry lessons, we get to percent yield. Percent yield is one of the easier layers of stoichiometry, but still try your best to understand it so when you get to these in a problem, you have no trouble with it. So percent yield is simple because it's really just a formula. If you have all the information, you just stick it into the formula, work out some numbers, and get your answer. Sometimes you may have to do a little bit of stoichiometry to get to that point, but once you get there, it's just a simple formula process. So what percent yield is, though, is it's a ratio of the actual yield to the theoretical yield. Sometimes the actual yield may be referred to as the experimental yield. So the actual yield is when you go into the lab and you do your chemical reactions, you produce some product. The mass or the amount of product you produce in that literal experiment is called the actual or the experimental yield of your chemical reaction. Your theoretical yield is what you calculate on paper. So when you do your math, you do your stoichiometry, and you get your answer at the end for how much product you produce, that is called your theoretical yield. It is in a perfect condition, perfect world scenario, if this reaction went to completion with no problem, how much you should produce. There are some things that may cause your actual yield to not match the theoretical yield. Maybe you didn't let the experiment run long enough. Maybe your dishware was uh, dirty or compromised. Maybe your experiment was in the wrong conditions. So there are things that can happen in the lab setting that causes your experiment or your chemical reaction to not go the way it should. So your actual yield doesn't fully match your theoretical yield. So the ratio between that actual and theoretical yield is what we call the percent yield. So the way we figure out percent yield is pretty simple. Percent yield is going to be equal to the actual yield value divided by the theoretical yield value times 100 to change it to a percent. And it's really that simple. So let's just take a look at an easy, simple problem. So let's say we do a reaction. And in this reaction, we produce 80 grams of product. So my actual yield, I'm just going to abbreviate actual, was ACT, is 80 grams. So in my experiment, I produce some product, I take that product, put it on an analytical balance, I got 80 grams. But when we did our stoichiometry before the experiment, we went through our calculations, we went through our math, and it said we should have produced 150 grams. So theoretically, we should have had 150 grams. So 80 is not 150, so this is not a match. So something has happened in our reaction that our product amount we produce wasn't the full amount. But we're not going to worry about the y for right now. We're just going to worry about how do we calculate the percent yield. So we just use a formula. So percent yield, I'm just going to put percent y is equal to the actual over the theoretical times 100. So you just take these values, plug it in. So the actual was 80, theoretical was 150. So 80 divided by 150, I get 0.533 repeating. Then I times that by 100. So my percent yield for this reaction is 53.3%. Not very high. So something has clearly gone wrong in our experiment. Like I said, it could be dirty equipment. It could be not enough time given. Maybe the temperature or the pressures were wrong. But something has happened in our reaction that our actual yield did not meet our theoretical yield. And thus we have a percent yield of 53.3%. Let's look at another problem. So during a reaction, you should theoretically produce 60 grams. So theoretically, we should have 60 grams. We only produced 80% of that amount. So our percent yield is 80%. What was your actual yield? I'm looking for the actual this time. How much did I really produce in the lab setting? Well, what I'm going to do is I'm going to take these values and stick it into the formula just like we did. So percent yield equals the actual over the theoretical. So let's just take these values and plug in. Difference here is I'm starting with a percent this time. I got to plug that percent in, but I can't plug it in as a percent. So I got to divide the percentage by 100 to change it to a decimal. So if I divide that by 100, it comes out to 0.8. I take that 0.8 and I plug it into the percent yield. So I got 0.8 right here. The actual is what I'm looking for, so that's going to be X. Theoretical is 60 grams. So I'm going to put that for theoretical. Now we just do a little bit of algebra. The way I'm going to do that, I'm going to stick 0.8 over 1. I'm going to cross multiply. So 1 times x is 1x. 0.8 times 60 is 48. I divide by the value with x. 1's cancel out. X equals 48. 48 what? Actual yield is measured in grams. So in this lab setting, we actually produced 48 grams when we should have produced 60. Let's do another one. This is the way you'll probably typically see it in an actual stoichiometry problem. So if you have 5 grams of hydrogen gas and excess oxygen gas, how much water by mass could you theoretically synthesize? If your actual yield is 40 grams of water, then what was your percent yield? Alright, let's break this down. Well, got to have a reaction first. Since we're doing hydrogen gas plus oxygen gas and synthesizing water, that's going to be 2H2 plus O2 yields 2H2O. I have 5 grams of hydrogen gas. I got excess oxygen gas. So I'm really not going to worry about oxygen. And I'm looking for the mass of water theoretically. So let's figure that out first. So I got to do a mole conversion and then convert those moles to water and then find the mass from there. So I got 5 grams of H2 over 1. Do my mole conversion. 1 mole of H2 is 2 grams. So that cancels out grams of hydrogen gas. Now I need to change moles of H2 to moles of H2O. So moles of H2O go on top. Moles of H2 go on bottom. To get the values here, I use my balanced equation. It's a 2 to 2 ratio, so there's 2 hydrogens for every 2 water. That cancels out my moles of H2. Once I get to this point, I got to change moles of H2O to grams of H2O. So 1 mole of H2O is equal to 18 grams of H2O. And that will cancel out my moles, leaving me with grams of H2O. So that should be my stopping point. Now we can do a little bit of math. So 5 times 1 divided by 2 times 2 divided by 2 times 18. Theoretically, in this experiment, we should produce 45 grams of water. So there's our first answer. So we should produce 45 grams of water. But if we only produced 40 grams, what's our percent yield? So the actual amount we produced, our problem says, is 40 grams. Our theoretical amount that we calculated was 45 grams. So what's percent yield? So percent yield is equal to the actual over the theoretical times 100. Slide down a little bit so I got room to work. So the actual is 40, the theoretical is 45. 40 divided by 45 is 0.88, repeating pretty much. So 0.888 times 100 to change it to a percent is 88.8%. And there is our percent yield for this problem. So hopefully that makes sense to you. So as you can see, percent yield isn't that difficult once you get the information you need. It's really just taking those two values, sticking it into a formula, and solving for a third value. Stoichiometry leading up to it may be difficult, but the percent yield portion isn't too bad. But make sure you practice it, make sure you give it your best, and make sure you understand it. So just in case it gets rolled into some of your problems later down the road, you don't get tripped up. And I hope this video helps. And as always, good luck on your tests.